In this example, we are given p of x polynomial function as a negative 3x cube, negative 2x square plus 17x minus 2. And the first question is asking us to list all possible rational zeros of p of x. Okay, so we need to find rational zeros. Now, how do we represent our rational zeros? So rational zeros is p over q. Okay, so rational zeros is p over q, where what is p? P is the factors, all factors of constant a naught. Okay, a naught is a constant, so we have to make a list of every factor of a constant term on that polynomial, and our q is the factor of coefficient of leading term. In our polynomial function, which one is the constant? Negative 2. Okay, so every factor of negative 2 is p, and the coefficient of leading term, so this is our leading term and its coefficient is negative 3, and our q are every factor of negative 3. Okay, now can you tell me what are the factor of constant? Our constant term is negative 2. So what are the every factors of negative 2? So we are listing every number that divide negative 2. So what do you think? So what are the numbers that divide negative 2? Is positive 1, negative 1, positive 2, negative 2. Right? So we are looking for the number that divide negative 2. Divided by our q. Q is the factor of coefficient of leading term. So negative 3 is the coefficient of leading term. And now we make a list of every number that divide negative 3. So 1 divides negative 3, right? Negative 1 divide negative 3. Positive 3 divide negative 3. Negative 3 divides negative 3. Okay? So here we have this option for a p and this option for a q. Now we take every possible combination. Okay, so let's start, let's take 1 for p. Okay, and let's take all these q one by one. Okay, so if our p is 1 and our q is 1, so what is 1 divided 1? It is 1, right? Now let's take p as a 1 and q as a negative 1. So 1 divided by negative 1 is negative 1. Let's take 1 as a p and 3 as a q. So 1 divided by 3 is 1 over 3. Now let's take p as a 1 and q as a negative 3. We get negative 1 over 3. So we are done with 1. Okay. Now let's take negative 1 for a p. Okay, so let's take negative 1 for a p. So negative 1 divided by 1 is negative 1, which we already have. Negative 1 divided by negative 1 is positive 1. No need to repeat. Negative 1 divided by 3 is negative 1 over 3. Negative 1 divided by negative 3 is positive 1 over 3. Now let's take 2. So 2 divided by 1 is 2. 2 divided by negative 1 is negative 2. 2 divided by 3 is 2 over 3. 2 divided by negative 3 is negative 2 over 3. Now we have one last value for p, which is negative 2. So negative 2 divided by 1 is negative 2. Negative 2 divided by negative 1 is positive 2. Negative 2 divided by 3 is negative 2 over 3. Negative 2 divided by negative 3 is positive 2 over 3. So these are the rational zeros, okay? And from this rational zero, at least we can find one real zero, okay? So it helps us to find the real zero for our polynomial function. So let me write down that polynomial function here one more time. So our polynomial function p of x is negative 3x cubed, negative 3x cubed, negative 2x square, positive 17x minus 2. So this is our polynomial function, okay? Now, so here we have how many rational zeros? 1, 2, 3, 4, 5, 6, 7, 8 rational zeros. Now, out of these 8 rational zeros, at least we have to find one real zero to find the remaining real zeros, okay? Now, how we find the real zero? How we check whether these numbers are a real zero or not? What we do? We replace every x of this function by this rational zero one by one, okay? And the rational zero whose output is equals to 0, it will be our 0, okay? So let's start with 1. So let's start with 1. So let's replace every x of our polynomial function by 1. So this is negative 3, negative 2, that's negative 5, positive 17. Positive 12 minus 2, positive 10. So we get 10. So 1 is not a real zero. Now let's start with next negative 1. So you replace every x of a function by negative 1. Do we get 0? That's our target. So this will be positive 3 minus 2, 1 minus 17. Minus 18, so it does not give us 0. So negative 1 is not a real 0. Okay. So before fraction, let me use 2. Okay. So let's replace every x of this function by 2. You do not need to show this work. Okay. You can do this on your calculator. Okay. This is negative 3 times 2 cube is 8 minus 2 times 2 square is 4 plus 17 times 2 minus 2. So this is negative 24, negative 8 plus 34 minus 2. So what is this? Negative 32. Yes, this is 0, right? So when we take our x equals to 2, we get 0. So 2 is one real 0 for this function p of x. Okay. So we know the real 0 is 2. Now, to find the remaining real 0, you can check for negative 2, 2 over 3, negative 2 over 3, 1 over 3, negative 1 over 3. Okay, but you may get other number as a real 0 or you may not get. Okay, so here we will use synthetic division. Okay, we will factorize this polynomial function, and once we have our polynomial function in a factor form, it is really easy to find the real 0. Okay, now to factorize this, we use the synthetic division. Okay, so what is the first step of synthetic division? We write down coefficient of each term. So negative 3, the coefficient of square term is negative 2, coefficient of x is positive 17, and constant is negative 2. And we divide this coefficient by which number? Can you tell me a number that we will use here? By the real 0, which is 2. Okay, we are using real 0 to divide this coefficient. You drop the first coefficient as it is, negative 3, multiply with 2. Negative 3 times 2 is negative 6. So do not change sign. Negative 2, negative 6, negative 8, multiply with 2. Negative 16. This is positive 1. 1 times 2, 2. This is 0. So this 0 is our remainder r of x. Okay. Now our p of x is... Now, if 2 is a real 0, what is the divisor? How do we write down the divisor? We know real 0 is 2. X minus real 0. So, x minus 2 is our divisor, okay? So, x minus real 0 is divisor. Now, let's write down the quotient. Since the degree of our polynomial function is 3, the degree of quotient will be 2. It means this is the coefficient of x square. So this is the coefficient of x square, this is the coefficient of x, and this is the constant. So our coefficient is, so our quotient is negative 3x square, negative 8x, positive 1. We have our p of x in a factor form. Next, this is in a quadratic form. We have to factorize this quadratic form. Okay, now how do we factorize? Now we have a negative here. Before we factorize, let me factor out negative. Okay, so let me keep that negative in front. You just switch the sign of each term. So we have positive 3x square, positive 8x minus 1. Now, can we factorize this? So we have 3x square plus 8x minus 1. Which method we use to factorize this quadratic form? We use the AC method, right? So we multiply a and c. Our a is 3, c is 1. 3 times 1 is 3. And what are the pair of factors of 3? 1 and 3. Now, using these two numbers, can we rewrite positive 8x by adding 1 and 3 or by subtracting 1 and 3? Can we rewrite 8? No, right? It means we can't use a AC method here. Okay, so our target is finding the real 0. Okay, so for what x value this this factor is 0? 2, right? So we already know the 2 is a real 0. Now for what x value this factor is 0? How we find that? It's not easy. So what we do, we write down that factor and set it equals to 0. Okay, we have a quadratic equation, and let's solve this quadratic equation using quadratic formula. If you can't factorize, you use the quadratic formula. Okay, if you can factorize, you factor and find the x that make that factor equals to 0. So our b is 8, so negative 8 plus minus 8 square minus 4 times a times c is negative 1 divided by 2 times 3. So this is negative 8 plus minus 64, 4 times 3, that's going to be positive 12 divided by 6. So this is negative 8, positive negative 64 plus 12, that is 76 divided by 6. So let's take positive. So negative 8 plus square root of 76 divided by 6, and negative 8 negative square root of 76 divided by 6. So these two are the numbers, okay, that make our this quotient equals to 0. Now if that is the case, what are these numbers for us? These are the real zeros. Okay, so these two are the real zeros. So negative 8 plus square root of 76 divided by 6, negative 8 negative 76 divided by 6. So if you can factor, it's going to be easy, but sometime you may not be able to factorize that quotient in a quadratic form. If that is the case, use the quadratic formula, okay, and the solution of the x will be the real zeros. Okay, any question for this example? Okay, now let's go to our next section. Okay, and let's skip this part. Okay, this is from our section 3.4. So here we have the fundamental theorem of algebra, and what it tells is that if we have a non-constant polynomial function with a complex coefficient, then it has at least one complex 0. So we have a non-constant polynomial function, and if that non-constant polynomial function has a complex coefficient, then that kind of polynomial will have at least one complex zero. Okay, earlier we had a real zero, now we have a complex zero. What's the difference here? So real zero means these are the real numbers, complex zero means these are the complex number. So these are the number with I, with imaginary term. Okay, now here we have an example. Let's start with example. So our function is h of x, polynomial function. Okay, so we have this polynomial function h of x equals to x cubed plus 2x squared plus x. The first question, what is the value of multiplicity of k of the 0 at x equals to -1? Now to find the multiplicity, we need to factorize this. Okay, so let's factorize this polynomial function. Do we have anything common in each term? What do we have as a common in each term? X, right? So let's factor out x. So from x cubed, if we factor out x, we have x squared. From positive 2x squared, if we factor out x, we have positive 2x. From x, if we factor out x, we have positive 1. So this is our unit 5, okay? Section 3.5. Yes, we skip this one. So page 10, I think we did page 9, right? We did complete page number 9, right? Again,
Skip 10?
yeah, skip page number 10. And this is the section 3.5 first example. So we have the common factor x, we factor out x. Now let's factorize this quadratic form. So which method do we use here to factorize this? We use a FOIL method. So we get a 2 term. So what should be the first term? It has whose product is x squared, it has to be x. Now can we find a 2 number whose product is positive 1 and sum is positive 2? 1 and 1, right? So positive 1, positive 1. So we have x plus 1 times x plus 1. So which is x plus 1 square. Now let's write down the zeros, real zeros for this function. Now for what x value? This factor is 0. For what number this x is 0? 0, right? When x is 0, this x is also 0. Now for what value of x this factor is 0? -1. We want to have a 0, okay? So -1. Now let's write down the multiplicities. Multiplicity is the exponent of each factor, okay? So we have first factor x. What is its exponent? What is the power? What number do we have here? If it's nothing, it's 1, right? So 1 is the multiplicity for this 0. Now for this factor, what is the exponent? 2. So 2 is the multiplicity for this 0, -1. Okay, so it answers our part A. What is the value of k of the 0 x equals to -1? So when our real 0 is -1, our multiplicity is 2. So our k is 2. Now what about part B? Write h of x in the form of x plus 1 to the power k times q of x. So what is q of x? So we already have our h of x, right? So we already have our h of x in that form. So our h of x is x plus 1 squared times x. So what will be q of x? So we write down our h of x as a x plus 1 to the power k. Our k is 2 times q of x. Our q of x is x. So this is our q of x. We are comparing our h of x with this given form. Okay. So for x plus 1, we have x plus 1. For k, we have 2. For q of x, we have x. And our q of x is x. Okay. Any question on this part? Okay, now let's go to the next example. So here we have a factorization theorem, and what it tells is that we can always factorize our polynomial function, and those linear factors are always unique. Okay, and let's do that using an example. So here we have x equals to -2 is a 0 for this function f of x, and we have to rewrite this function in a factor form, okay, in a linear factor form. Okay, so we know x equals to -2 is a real 0. Now how do we write down f of x in a factor form? So our f of x is x cubed plus 2x squared plus 7x plus 14. We can't use the factorization rule that we have been using earlier, okay, like for our quadratic term. Now here this is a cubic function. We know x equals to -2 is a 0. If -2 is a 0, we already know one factor. What is that factor? Since -2 is already a 0 of a function, since -2 is a real 0 of that function f, we already know one factor. And what is that factor? X minus this real 0. So x minus -2 is one factor. Okay, so since this is the real 0, x minus this number -2, which is x plus 2, this is a factor. Okay, we already know one factor is x plus 2. If you have a real zeros, then x minus that real 0 is always a factor. Okay, now it's going to be very similar example that we did at first in today. So we divide, okay, we rewrite this function in a form of divisor time quotient. Okay, we write down our polynomial as a divisor time quotient q of x. We already have a divisor, so this is the divisor. Now we need to find the quotient, and you can use a synthetic division or a long division. We already use a synthetic division. Do you want to use a long division? Or but you can use any. Okay, so let's use a long division. So we divide this function. Okay, so we are dividing x cubed plus 2x squared plus 7x plus 14 by that factor x plus 2. Okay, we are dividing the function by that factor to get the quotient. Now the first step, you take the first term x cubed and divide by x. X cubed divided by x is x squared, and that is the first term of quotient. Now you multiply x squared and every term of this divisor. So x squared times x is x cubed. X squared times positive 2 is positive 2x squared. Do not forget to flip sign. If you are using long division, then you have to flip sign. This is 0. This is 0. Now we drop the remaining terms. So we have 7x plus 14. Now we take the first term 7x and divide by x. 7x divided by x is positive 7. Now we multiply positive 7 and every term of the divisor. So positive 7 times x, positive 7x, positive 7 times positive 2, positive 14. Do not forget to flip sign. So this is negative, this is negative. So this is 0, this is 0. So here this is 0. It is our remainder r of x, and x squared plus 7. This is our q of x, okay? So our function f of x is, divisor time, divisor is x plus 2 time the quotient is x squared plus 7. So we have our function f of x in a, this is our linear factor and this is the quadratic factor, and we cannot reduce this quadratic, okay? This is irreducible quadratic factor. So this is how we can rewrite or we can factorize our function, okay? So we have the two factors here, x plus 2, x squared plus 7. And that's what we want here. So we want our function to be in a linear factor and an irreducible quadratic factor. So this is our linear factor. Why this is linear? Because x has a degree 1, right? So this term has a degree 1. And this is our quadratic factor. We have a power 2 here, okay? And we cannot factorize. This is the we cannot factorize here, and that's why we have the irreducible quadratic factors. Okay, any question on this example? So it's basically we are doing a review of a long division, okay? Can we start the next? Okay, now here, so we have the linear factorization theorem, and if we have a polynomial, we can also rewrite that polynomial as a product of linear factor, okay? And let's do example here, okay, not here. Okay, so here we are asked to find all real zeros of this polynomial function, okay? So our polynomial function is p of x equals to x cubed negative x squared negative 3x. To find the real zero, we have to rewrite our polynomial function in a factor form, okay? That is the easiest way. Now can we factorize here? So we have each term has a x as a common, right? So let's factor out x. So let's factor out x. So if we factor out x from x cubed, we have x squared. If we factor out x from negative x squared, we have negative x. And if we factor out x from negative 3x, we have negative 3. So we have x as it is. Now which method do we use here? We use a FOIL, right? So what should be the first term whose product is x squared? It has to be x. Now can we find two numbers whose product is negative 3 and sum is negative 1? Can you think of a two number whose product is negative 3 and sum of those two numbers has to be negative 1? Do we have any number? Think of a two number whose product is negative 3 at first. So it has to be 1 and negative 3 or negative 1 and positive 3, right? Now when we add those two numbers, do we get negative 1? Negative 3 plus 1 is negative 2. 1 plus negative 3 is negative 2. So we do not get, it means we can't use a FOIL. So here we will use our quadratic formula to factorize this quadratic formula, okay? So let's use quadratic formula, which is negative b plus minus b square minus 4ac divided by 2a. Okay, so our b is negative 1 plus minus b is negative 1 minus 4a is 1, c is minus 3 divided by 2 times a is 1. So this is positive 1 plus minus negative 1 square is 1 negative 4 times 1, negative 4 times negative 3, positive 12 divided by 2. So this is 1 plus minus square root of 13 divided by 2. So let's take positive, we get, so we have two number here. One is 1 plus square root of 13, sorry, this is 13, not 17. And the next is 1 minus square root of 13 divided by 2. So these are the two other numbers, okay, or real zeros for our p of x. And we have one more real zero. So for what x value this factor is 0, right? So we have 0 as one real zero, we have this number as the second real zero, and we have this number as the next real zero. Now can we rewrite our p of x in a factor form? We already have the three real zeros, right? So how do we write down our p of x in a factor form? If we know real zero, then factor is x minus that real zero is a factor. Let's start with 0. So x minus 0 is x. So x is one factor. X minus this number, x minus 1 plus root 13 divided by 2. This is the second factor. X minus this number, x minus 1 minus root 13 divided by 2. So these are the factors for our polynomial function, okay? So once you have the real zero, is every time x minus that real zero, okay? X minus the real zero is a factor. Okay, now in the similar way, let's do number 2. We are asked to find all real zeros, okay? So we have a function f of x is x to the power 4 negative 2x cube negative 3x square negative 2x plus 6. Okay, this is the polynomial function. We have to find all zeros. Now can we find at least one? Okay, now if we have at least one zero, it's gonna be easy, right? Now how do we find the real zeros? Using the definition of a rational zero. Okay, so let's find rational zero first. So rational zero is p over q. What is p? P is the every factor of constant 6. So 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. So these are the numbers that divide our constant 6 divided by every factor of coefficient of leading term. So this leading term has a coefficient 1. So the factors of 1 is positive 1, negative 1. Now from here, you take each p and divide by these two q. What do we get? We get the same p. Since it's 1 and negative 1, we get 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. So these are the rational zeros. Now out of these rational zeros, there is at least one real zero. And how do we find which one is real zero? You replace every x by this rational zero one by one, and the number that give output 0 is our real 0. Okay, let's start with 1. So let's start with this one. So this is 1 minus 2, minus 1 minus 3. So this is 1. 1 minus 2 is minus 1, minus 4, minus 6 plus 6. Yes. So when we take x equals to 1, we get 0. So we have 1 as a real 0. Okay, so we know real 0 is 1. Now you can check for -1, +2, -2. They might be real 0. Okay, just use your calculator, and whichever gives the output equals to 0 is the real 0. Now if you do not want to use calculator, we have 1 0, and if we know 1 0, we can rewrite our function in a factor form. We factorize and we look for a number that make each factor equals to 0. Now let's rewrite this function in a factor form. Okay, we have 1 real 0. We use the synthetic division here. Okay, the coefficient of x to the power 4 is 1, coefficient of x cube is -2, coefficient of x square is -3, coefficient of x is -2, and constant 6. We are dividing this coefficient by the real 0, 1. So you drop 1, 1 times 1, 1, this is -1 times 1 is -1, this is -4 times 1 is -4, this is -6 times 1 is -6, 0. This is our remainder r of x. Okay, so how your function looks like now? Our function f of x is, so what is our divisor here? We know 1 is a real 0. So what is the divisor? X minus 1. So x minus 1 is the divisor. Now what will be our quotient here? This function has a degree 4. The quotient will have a degree less by 1. So it will be 3. So this is the coefficient of x cube. So this is x cube, x square, x, and this is constant. So 1 times x cube, so we have x cube negative x square negative 4x negative 6. So this is our quotient. Now we still need to factorize this cubic term here. Now for that we find a real 0 for this expression. We find a number that make this expression equals to 0. Can you think of a x that make this expression 0? And that number will be from here. Okay, so for what x value this quotient is 0? Let's try -1. So if our x is -1, this is -1, this is -1, this is -2, and this is +4. So -1 is not. Let's try 2. So 2 cube is 8, right? 8 minus 4, that is 4 minus 8. Minus 4, okay, this is not. What about -2? So -2 is -8, -4, +4, -6. Is it 0? No, this is not 0. Okay, now so this is not. Let's try 3. 3 cube is 27 minus 9 minus 12 minus 6. Is it 0? 9 minus, okay, -9, -12, -21, -6, -27. Okay, yes. So this is another real 0. Okay, so we have 3 as a real 0 for this term. Okay, now we divide this factor, okay, this expression by 3 using synthetic division. So write down the coefficient. Coefficient of x cube is 1. Coefficient of excuse me, coefficient of x square is -1. Coefficient of x is -4 and -6. We are dividing this by the real 0, which is 3. You drop first times 3. This is +2 times 3, 6, minus 2, sorry, not +2, +6, 0. This is our r of x. Now what will be our quotient? How do we write down the quotient? So this has a degree 3. So the quotient will be less by 1. It will be degree 2. So this is x square, this is x, and this is constant. So our function f of x is, we already have a first factor, x minus 1. So what is our second factor? X minus 3, okay, because 3 is a real 0, x minus 3. And the third factor is this quotient, x square plus 2x plus 2. Now we have a quadratic expression here. We can't use a FOIL here because we cannot find a number whose product is 2 and sum is 2. So we can't use a FOIL here. We have to use a quadratic formula here, okay, to factorize this one. So let's factorize this using quadratic formula, which is negative b plus minus b square minus 4ac divided by 2a. So negative b is our 2, so negative 2 plus minus 2 square minus 4, a is 1, c is 2 divided by 2 times 1. So this is negative 2 plus minus 4 minus 8 divided by 2, which is negative 2 plus minus square root of negative 4 divided by 2. Now how do we simplify square root of negative 4? What is that equals to? Square root of negative 4 is 2i, okay? Square root of 4 is 2 and square root of this negative is I. So we can rewrite negative 4. We can rewrite negative 4 as a negative 1 times 4. We know I square is negative 1 times 4. Okay, so square root of I square is I, square root of 4 is 2 divided by 2. Now we factor out 2 in the numerator. So negative 1 plus minus 1i, this cancel. We have negative 1 plus I, negative 1, negative I. Now what kind of numbers are these? Are these real number? These are the complex number, okay? So here when we replace our x by these two number, we get a 0. Okay, when we replace our x of that function by this complex number, we get output 0. It means these two are the complex 0 for this function. Okay, so our f of x looks like now, f of x is x minus 1, x minus 3, x minus this 0, minus 1 plus I, x, sorry, this is times x minus this 0, minus 1 minus I. So here we have our function f of x in a factor form. So we have 1 factor, 2 factor, 3 factor, 4 factor. This function has a zeros, so when x is 1, so 1 is 0, 3 is 0, from here negative 1 plus I is 0, from here negative 1 minus I is 0. So out of these 4 0, what kind of zeros are these? These are the real zeros. 1 and 3 is a real number, so these are real zeros. These two are a complex number, so these are the complex 0. Complex 0. Okay, any question up to here? Now, if you look at those two complex zeros, what kind of complex numbers are those? So we have two complex 0 here. Okay, so we have negative 1 plus I and negative 1 minus I. So these two are complex 0. Now, what kind of complex number are these? what do we, so we have negative 1 plus I and we have negative 1 minus I. What do we call these two complex number? These are the conjugate of each other. Okay, so the conjugate of this complex number is this one, the conjugate of this number is this one. Okay, conjugate means you see everything is same except the sign of I. So here I is positive, here I is negative. That's the only difference, but everything is same. Okay, so these two are the conjugate complex number. Now from here what we can conclude is that, okay, so if we have any number as a, okay, let's say we have some polynomial function p of x. We don't know what is that, but we have that function. And if one real zero of that function is negative 3 plus 2i, let's say we have a polynomial function p of x, and that p of x has one complex zero which is negative 3 plus 2i. Now the next complex zero will be its conjugate. So what is the conjugate of negative 3 plus 2i? What is the conjugate of negative 3 plus 2i? It is negative 3. You change the sign of item. It is positive negative 2i. And this conjugate is also a complex zero for the same polynomial function. Okay. So if you are given one complex zero for any polynomial function, then you have to know that its conjugate is also a 0. Okay. So in the similar way, so if the same has a same polynomial function has a 3 minus I as a complex zero, then what will be the next complex zero? It will be 3 plus I. Okay, and we have this example, I think in our exam 4 review. It should be the okay, now here the very last question. So given that 1 minus 2i is a 0 of p of x, find all three zeros. Now out of that three zeros, can you tell me one zero without solving anything here? It's going to be 1 plus 2i. So we already have 1 minus 2i. Its conjugate is 1 plus 2i is the another zero, and your target is to find the third real zero. Okay, in the similar way here we have 3 plus I as 1 0. Since this is a complex zero, its conjugate 3 minus I is the second zero. Okay, and we will learn how to find the third zeros.